Alright, welcome to today's lesson on trigonometry, and we're going to go one step further and have a look at a whole lot of questions where the unknown side is in a bit of a tricky position. And I'll show you what I mean, but we'll just dive straight into it. So, whoops, don't want to do that. Here is our first problem. Now, as always, we have a triangle. It's a right-angled triangle. We know because of the right angle there, the hypotenuse is opposite, so it's 6. The missing angle, or the angle we know, is 22 degrees, and the x is the one we're trying to find. So let's have a look. First of all, we're going to label the sides. So we have hypotenuse here. We have that's opposite because it's opposite the angle, and adjacent is next to the angle. And we notice straight away that we've been given sides O and H. So the ratio we're going to use should be sine. So we'll write it down, O over H. And then we're going to substitute the things we know into this formula. So we have the angle here, which we know from the diagram is 22. We have O, which we know from the diagram is x. And we have H, which we know from the diagram is 6. Alright, so as previously, we say to ourselves, what is the sine of 22? And to do that, we can do it on our calculators, or we can flip over here to the trig tables. We find the angle 22, we find the sine 0.3746. We flip back here, and we, instead of the sine, 3746 equals x divided by 6. We know to think to ourselves that when a number is divided by 6 and the answer is 0.3, then that should mean that we need to multiply the 6 by the 0.3, so 6 times 0.3746. And we do that in our calculators, and we will get something. Alright, so 6 times 0.3746, if you're doing it on your calculators, you should know that it is 2.2476. So that is the missing side, that is x. Oh, yep. So x equals 2.2476. Now, so far, that has been no different. This is the process we know, and we're going to apply it to a different context over here. Same triangle, right angle triangle. We're going to label the sides. We have our reference angle here, so the 4 is the A, the x is the hypotenuse. So we can see straight away that the relationship we need is cos. Alright, we notice something straight away. If we're looking carefully, we might notice that now the unknown side is in the denominator. So let's do the same steps. We'll flip over here to our trig tables. We'll find cos of 31. 31 degrees is here, and the cos is 0.8572. So come back here. Well, instead of the cos 31, we write 0.8572 equals 4 over x. Now we think to ourselves, if I have 4 divided by something, and the answer is 0.8, that should mean that the thing I need to do to find out what the missing number is divide the number I know by the decimal. And that should give me a bigger number. So 4 divided by a big number will give me a decimal. Okay, if this decimal was bigger than 1, I would have to do something else. So now 4 divided by 0.8572 equals 4.66634. And I went that far to show you that the 666s didn't keep recurring. Alright, so now think to yourselves, 4.6 is bigger than 4. And so 4 divided by a number bigger than itself produces a decimal. So 4.6 is a reasonable answer for the hypotenuse because it's longer than the side we know. Alright, so we'll have one more go at it down here. So we'll label the sides first of all. We have next to the angle is A, opposite the angle is O, and just to make sure, the right angle is there, and that means that's the hypotenuse. So I've been given O and A, which means that the ratio I'm using is tan, and so then it's tan of over x. Oops, I should have just written A over H. I've just jumped the gun there, so we'll redo it down here. Tan of 62 equals 6.2 divided by x. So again, we flip back over here to our trig tables. We find 62, right here, and I'm looking for the tan, 1.8807. So I write it in here instead of the, oops, not that. 1.8807 equals 6.2 divided by x. So I think to myself, for this to work, I need to divide 6.2 by the 1.8. So x equals 6.2 divided by 1.8807. And this will give us an answer of 3.296. Okay, now just thinking to ourselves, 6.2 divided by a number smaller than itself gives us a number bigger than 1.8. In short, there are 1.83s in 6.2. So this number checks out. It is approximately the right length for what we needed to do. So we can rewrite it here clearly if we want to. 3.296. Alright, so this is the process that we've been using all the way through. We need to write the ratio every time. We need to find out the decimal that we're dealing with, which is the ratio of the angle. And we need to either multiply it in some situations, but for today we're going to be dividing to find the missing number. Alright, and most of the time you'll notice that it's going to divide the side by the ratio. So side, ratio. Alright, so if you forget what you're doing, just side divided by ratio when you get to that step, and you should get the right answer.